Patrick, welcome to the show, man. How you doing?
Thanks for having me on. I'm doing well. How are you, Trevor?
Doing all right. I'm just going to come out swinging here, and we'll dig into some of the engineering later. But why do you have the best bump stops in the game?
My bump stops are the only bump stops on the market that offer active compression damping. In the same way that your shocks actually shed energy, you want your bump stops to do the same thing. So Perry Parts bump stops behave similarly to how a hydro bump does, where it actually damps the impact and absorbs and sheds that energy, as opposed to being more like a spring, where traditional bump stops are a rubber or a urethane spring, and that just all gets passed back into your suspension, and your shock then has to shed that energy. And your shock is tuned to handle the weight of the vehicle and the weight and the stiffness of your spring, not another spring that's 4 to 8 times the spring rate. Right. So that's the goal. It's almost like a little miniature coilover at the end of your suspension travel to absorb the hard hits, protect your suspension, and deaden those hard hits.
Okay, yeah. So you kind of talked about it a little bit, but why are bump stops like so important in the suspension system?
Yeah. I think that particularly with respect to the Toyota platforms, the Toyotas are so close to the bump stops from the factory. A lot of people don't realize this, and I didn't realize this before I got into this, before I ran my first set of bump stops. You are sitting like half an inch off the factory bump stops at static ride height before you even start working your suspension, right? And so as soon as you get into any amount of up travel, you're in bump stop. And so it makes a substantial difference, especially when we start adding weight to these vehicles, when we start wheeling these vehicles. And the real goal is, how do you maximize suspension travel while also, protecting the suspension and balancing that amount of up travel along with the amount of suspension travel limitation as well, right? You want to create a good hard stop and also shed that energy over a longer distance.
Right. Dude, anytime I'm under my third gen crawling around, I'm like, man, I just feel like the bump stops there's not a lot of room there. And I've heard other people complain about it. And obviously when we hit those factory stops, it's rough.
Yep.
So,
yep.
Yeah, just having something to damp it a little bit would be pretty sweet.
That vintage of Toyota to the third gens and the 100 series Land Cruisers, you're even closer, and you're 4 front bumps. And the really interesting thing is, like, you're so close, and the lower control arm puts a ton of shear on the bump stop, because especially if you engage earlier, you're pushing the bump stop to the side as you're swinging that control arm upward.
Okay.
So it's more than just, the factory bump stop is a metal cup with a hockey puck in it, essentially. There's just nothing going on there, right?
Right.
So,
yeah. So you mentioned your bump stops are a little bit like some what am I looking for? Air stops. Tell me how they differ a little bit, and how much better they are than, say, a stock bump stop.
Sure. So, at the end of the day, anything that offers damping inherently means it is a dynamic product, right? I see a lot of competitors that advertise, compression damping or smooth progressive damping, and they test it by compressing it in a spring compressor or something of the sort. What they're demonstrating there is a progressive spring rate, which is also something you want. But inherently, damping means shedding energy, which means movement, right? A hydro bump works by, there's an air chamber in there. You compress the air chamber, or you add compressed air to that air chamber, and that's the spring part of that bump stop product. There's also oil that gets forced through ports by a piston, and that's the damping. So as you actuate that hydro bump, the air provides a linear amount of resistance. So, for a given displacement, the air pushes back a certain amount, right? And that doesn't really change. But what changes is the damping. You push that faster, and it provides much more force feedback, and that's how damping adds to your suspension characteristics. What we've made is essentially a no moving parts damper. So in one product. I'm trying to find a good cross section for you here. I've got a whole bunch of them cut in half. So inside of one part, is that a good angle? Yeah. So the ports at the bottom restrict the airflow. The air chamber is actually the charge. And the really interesting thing is, so as you compress it, right, that airflow gets constricted by the port. But the other really cool part is then after you've compressed it and this part's now rebounding, that air has to get sucked back in. So it also means that it provides less force on rebound.
Yeah.
So you don't get bounce back as much as you hit, and then you keep moving and it rebounds slower.
Okay.
And you know, I've been gathering a whole bunch of tools, and I've learned a lot about both the manufacturing process. We can get into that a little bit later, but also tuning the product. Last year, I bought a suspension dynamometer, which is this, you know, I had to run a dedicated circuit for it.
Yeah,
it's a pretty badass piece of tech. There's a 3 horsepower motor hooked up to a yoke, and it just squishes things really fast. And so, you know, that allowed me to start playing with different geometries and different port sizes, and in the same way that, you know, a shock company will change the shim sack and change the viscosity of their oil and play with different springs, I can do all that with this product as well. You can change the density of the internal structure to make it stiffer or softer, right? You can change the size of the ports to change the amount of damping, and so you can tune it like a shock,
right?
But it's one part. It's just one polymer product, which is super cool. Yeah,
that's cool.
Sorry, I started to go off the rails.
No, you're good. No, you actually answered my next question, was like how do you tune them? And like, because obviously with the hydraulic ones, you can, you know, change your air pressure or shim them or anything, you know, something like that. Whereas what you're doing is, you know, basically, it's sort of the same thing, but it's just in a very different way.
Exactly. The thing that's really interesting, so like on a hydro, you can change the port the port size or the shims, and it's independent of the spring rate, right? But you know, you looking at these two parts, right? The one here on the right, which is much stiffer, has a lot less air volume,
right?
And so you need to then play with the port diameter if you want to have the same amount of damping as the previous version. And so they're all interlinked and compounding. And so having the ability to measure it and visualize things has been super useful. That was a really cool tool to add to the shop.
Yeah. How do you test them when you don't have access to all of these different vehicles that you're putting them on? Obviously you have tools and whatnot, but are you having to input certain specs into this machine? Sorry, I'm not as technical as you are, but are you?
No, that's a great question. It's actually something that that has been a focus area of mine over the last year or so. Is so being able to say, hey, this is the vehicle. Basically, there's a few things you care about. You care about the vehicle weight, the spring rate that the customer is running, and the leverage ratio. So like a control arm, a long travel control arm has a much higher leverage ratio on the bump stop compared to a factory one, right? You add 3.5 inches to the control arm width, you're just pushing with a bigger lever. So those things give you a really good starting point. It's not perfect, but I've got a huge Excel spreadsheet. And I started with what I knew worked, which was, you know, I love my setup on my GX. And so I said, okay, take this, you know, take the bump engagement point, take the leverage ratio of the control arm. I scanned it all into CAD, measured everything. I should have just done it with a ruler or a tape measure, because it would have been, you have fun with the tools you have, and sometimes you realize it's too much. But anyway, I got all those measurements, I got all that information. I started to actually be able to make a kind of a formula, right? And that gets you really close. That gets you, I'd say, 10-15% away from where you probably want to end up.
Okay.
Right? And then it's, okay, let's get these in the hands of product testers. Get feedback on fitment, because that's a really interesting one. There's a lot of things that, yes, it might bolt up to the same location, but can I make it easier for people to install? And then the next thing is like, hey, go out, thrash on them, you know, get a feel for ride feel, tell me what you do and don't like. You know, we can move the hard stop location around inside the product. We can make it more dead blow. We can make it softer. We can make it stiffer. It's from there. It's a free for all.
Yeah,
it's a lot of fun.
Nice, nice. Talk to me a little bit about the manufacturing process. Obviously, you have all of your printers behind you there. Are all of them 3D printed, like with a polymer, or do you go into a different production phase after the 3D printing?
No, so everything is 3D printed.
Nice.
So when I first launched this business, we were using filament,
Okay.
and the printers were modified to print flexible materials well, faster than you normally could. They were kind of tailored for that purpose. And early on, that was a really good way to make it, but I ran into a few things. The biggest one being the material supply chain for 3D printing filament is not reliable enough to make a good, robust product, especially for something that's going into a vehicle.
Yeah.
And so the early prototypes that I ran, they worked great, but then like a few months later, the material would be stiffer, the material would be softer, and they didn't have a tight enough control over the raw material that they were providing me. I started to add some checks and balances into the process, but at the end of the day, I realized that, one, if I could buy my material by the ton instead of by the kilogram, it would be a lot more consistent. And I started looking into the tech specs for some of these materials for injection molding purposes, and they were like 3-4x the tensile strength.
Wow.
And ultimate elongation at break, so how much you could stretch it before it actually would break was another 1 to 2x. So going from 4 to 5 to 600%. So across the board, it was a win, right? The issue is then, I don't know how much background you have in 3D printing.
Not a ton.
You know what filament is, though,
Yeah,
right?
absolutely.
So imagine just having a whole bunch of BBs.
Yeah.
And figuring out how to 3D print that. How do you process that, right? So I found this guy in Spain. He had this pet project, and he had made a print head to print these pellets. And I was like, hey, like, can you do a limited production run for me? I gave him a chunk of change, and he made some heads for me. And they worked pretty well. But eventually I was like, all right, like, I have a bunch of things that I want to change about this part. So I bought a CNC machine, machined up my own print heads, and everything in-house now is a in-house machined.
Nice.
I send some stuff out to get laser cut. I have some laser cut pieces too, and I'm not buying a 10 kilowatt laser.
Yeah.
I would love to, but my wife would not be thrilled.
Right. How many printers are you running in your shop currently?
I have 20.
20. Nice.
Yep.
So you're able to pump out
Yep.
quite a few bump stops like in a day, right?
Yeah. We can do. We're doing about. If the farm is at full tilt, we can do about 1,500 pounds every 4 weeks.
Wow. Nice.
And so, it's been like the benefits of doing pellet extrusion are huge. You no longer have to take this big spool of filament, load the printer, push all that through, and that can clog sometimes too. The new design for my print heads it's far more serviceable. You just keep the hopper topped off. You never have to remove a spool. You never unload anything. And the print quality is about on par with filament, which is really huge. A lot of folks that are doing the pellet extrusion, they're not getting there, right? So there's a lot of benefits, but at the same time, you have to tailor it for the specific material and the product that you're doing. It's a little bit less turnkey. 3D printers have gotten really good. I've been 3D printing for like 15 years, and they were pretty terrible for a while, 10 years.
Yeah, they've come a long way. I keep trying to convince my wife to let me buy one just so I can, make parts for my own car. But kind of moving on just a little bit here, but like I've seen a lot of people have like rave reviews for like in the off-road space for your products. Are you like continually seeing that throughout the market where people are just loving the product, or?
Yeah, I do. Especially early on with a product release, like we came out with Nissans earlier this year, and it's really important to me, like that the first 10 orders, I check in with those people every few months, because some people just take a while to install their product,
Right.
and you would hate to be like, hey, I sent out these parts 3 months later, because life happens, right? 3 months later, you finally got around to installing them, and you didn't love the way they fit, or they were too stiff, or they were too soft, or whatever. So a big part of my business is just getting customer feedback. And there's this common perception amongst people of like, oh, well, this is the product. And it's like, well, no, the product can change. There's no reason for me not to improve my product.
Yeah.
I really want to hear that, right? But generally, no, not generally, everything that becomes mature is a really robust and good product.
Absolutely.
And yeah, I mean, like, one of the big things when I went from the old manufacturing process to the Gen 2 process was, these Gen 1 customers got me off the ground. And the product, I knew it was going to be better, and I was like excited to make the product better. And then I got the dyno, I ran it head to head to the Gen 1. I was like, this is so much better. Like it was like night and day.
Yeah.
And so I reached out to all the Gen 1 customers. I'm like, hey, like I've come a long way. Let me send you the newest, latest, and greatest, right? Like, so we did an upgrade program over the summer.
That's cool.
Yeah, it was super rewarding, and I got to see how the Gen 1s held up, and for the most part, they all did really well. And so it was super cool to like get that feedback, build a relationship with the customers. So yeah.
Nice. No, that's cool. That's always like, positive reinforcement for yourself, where you're getting those products back and seeing how well they perform, but also being able to, hand out products, for free, basically, to just be like, hey, thank you for being with me on this journey. So
yeah, exactly.
Nice. Do you have any plans for moving into maybe not the off-road space? Like my brain goes to like track cars in particular. Yeah.
Yeah. So I've got a couple of buddies that have been hounding me, two different spaces. A couple of buddies that have GR86s that track their cars. And I have an old E36 M3 that has several 3D printed parts on it. Some that I really think would be cool to bring to market. I think it's interesting, like, even in the off-road community, it's hard to break over from Toyota to Jeep.
Yeah, yeah.
So to go from I make parts for Toyota 4x4s to I make parts for your track car is a very different dynamic. Mm-hmm. That said, like, I do have a few things that I think would be really big value adds, particularly in like the bushing space, right? Kind of my niche is these flexible polymer parts. Mm-hmm. And then another thing, I love to ride dirt bikes. And I've got one thing on my dirt bike that has been super cool. It is really expensive to make. And so I'm not sure if that one's really a viable product, but it might be something that goes up on the site. And if people choose to buy it, they can. Otherwise, I just get to run it myself.
For sure.
So,
yeah, I was kind of scrolling through your website the other day, and you got some stuff for motorcycles listed on there. Kind of dive into that a little bit.
So that's a great example of, hey, I made it, and it would be cool to put it up on the site.
Yeah.
So the Ducati Scrambler gauge relocation kit, I had a Ducati Scrambler, and I got really into the cafe racer look for a while. And so, that was one that was like, hey, like, this product is done. It bolts right up to the bike. Why don't I share it with people, right? And then the BMW, the 1200 GS luggage rack, that was another one that, like, I wasn't happy. The whole name of the game on bikes is weight. Right. And I wasn't thrilled with all the existing rack options. So made one out of aluminum, laser cut. And that one was super cool because it actually, so in adventure biking, if you've got really big, solid luggage bags, you can break your leg.
Yeah.
It's a 600-pound bike, right? And so if the rack can fold out of the way, can save your leg, right? Now you're only going to get a couple of folds out of it before the aluminum's not happy with you. Right. But, I've dropped my bike plenty of times, and it's not an issue yet. So.
Nice. No, that's cool. Yeah. That's super cool. I just felt like maybe there was an opportunity there for you to move into maybe a different space. And I understand having, a niche and all that. But man, my brain went straight to track cars and motorcycles and all that, and I was like, there's so much you can do here.
Yeah, man. That's kind of one thing I tell people is my product is my process. I just happen to make bump stops. Right. Like being able to print with industrial grade materials, that's the real value add.
Absolutely.
And I mean, like I've said to some of my competitors, if you want to prototype products, and because I can simulate different durometers of material, right? It's all the same durometer, but by changing the density, you can get a similar effect, right? So I can help people prototype. I help this one company. It's a medical device company. They're doing biocompatibility work.
Wow.
So like a lot of like, it's more of diversification of like word of mouth sort of stuff.
Yeah, absolutely.
Yeah.
All right, so moving into your off-road experience here, we're just gonna hit it hard. How many rear ends have you blown up in your GX?
I'm on my fifth.
You're on your fifth.
And if I kill this one, I'm in real trouble.
Because you swapped a 9-inch into it, right?
I did 9.5.
Okay,
yeah.
Nice.
So I was down at Cruisers on the Rocks, which for anyone listening, if you've got a Land Cruiser, go. It was such a cool experience. But the last day I was running some of the harder trails, and I wanted to follow one of the Land Cruisers, one of the properly built Land Cruisers with a Tundra front end swap and all this other stuff. And I got the front wheel up over the rock, and then I started to load it up to get up over a ledge, and the rear just popped. It wasn't even cool. I got it on video, and it was just blew up, right?
Oh, man. So wait, did you put a Tundra rear end in it?
No. So one of the other guys, we were all talking about it after that happened, and one guy gave me sold me a 9.5 for $100 for $200, and then another guy gave me his gears, so the 410 gears, and then I got a 30 spline locker for an 80 series, and then what I did was I ran a laser level, got the center line of where the pinion bolts up to the axles, measured out some cut points, and I was actually able to preserve the lower control arm mounts, one of the upper control arm mounts, the sway bar mounts, not that I run them,
right?
Spring perches, hubs, all that from the GX axle.
Wow.
And so all I had to do was just chop the pumpkin out, sleeve it, put it into the GX axle, and yeah.
That's impressive. That's impressive.
I'm really stoked with how it turned out. It just worked.
Right. Right.
I expected all sorts of issues. But yeah, no, it was a fun project.
That's probably a good thing for you, though. I mean, I watched some of your stuff, and you wheel it pretty hard. So.
Yeah.
But
the first time we blew up an 8-inch, we were out in Moab, and I was riding a dirt bike, and my wife was driving, and I said, "Do it again, but this time like you mean it." and then the other 3 times were all my fault. Like it wasn't her fault, but I think it's funny. That's kind of how we kicked it all off.
Yeah. That's awesome.
Yeah.
So, for the listeners that don't know, Patrick was you were an engineer at Apple, correct?
That's right.
All right. Yeah. Tell me a little bit about that role and what you did there.
So I started out on the Mac manufacturing design architecture team. And what that team does is it interfaces really early on with the designers. And my old boss said it really well. She said, "We can't really say no. We just have to figure out if you can make it." And so it was a lot of conversations of new materials, new manufacturing processes, investigating new vendors, right? Like traveling abroad and seeing what's the latest and greatest. And I was there for about a year, and then I moved over to the manufacturing design execution team. And so that's where, on the architecture side, a lot of the things you work on doesn't necessarily make it into a product. I would say you probably have a 10-15% chance of what not that you necessarily fail, but maybe it's too expensive.
Yeah.
Maybe, the chip isn't ready yet, whatever, right? You move over to the execution side, and it's all right, this is releasing on this day. Or at least, this quarter, whatever.
Yeah.
And that's a lot more. That was cool because it was there have been several instances where I didn't know I would have to be traveling, and then I'm flying to Shanghai like on Monday, right?
Wow.
To go put out a fire, right? And it was a super cool experience because you start to realize that manufacturing is this moving thing. It's like the way that we make things, the public perception is, hey, you lock it and that's just what it is. And then you realize that everything is continuously being improved and should be improved over time. It was a really cool experience.
Yeah.
And I got a lot of exposure to cool new locations, working on some cool products. My first product was the Mac Pro, the cheese grater, the most recent one.
Yeah.
And then I owned the server rack version of that as well. And then I worked on what came next? I did a little bit of work on the studio, but not a ton. And then I worked on the iMac, the most recent slim, colorful iMac. And then I did a little bit of work with some of the new laptop lineup that came out recently.
Nice.
Yeah. So it was a really fun experience. I miss it a little bit, but I also love being able to do what I'm doing now.
For sure.
You know?
Yeah. What ultimately led you to leave that job and, pursue this full time?
So I wanted to go out wheeling. We had a trip planned to Mendocino, and I broke a competitor's product the weekend prior, and I couldn't get anything soon enough. They had like a 20-day lead time at that point, and I had been playing around with this new to me material called TPU, thermoplastic polyurethane, and I printed one, and the first spin was too soft and too tall, but it was really cool to try, and it was kind of viable. Like, we went out and we're like, these are halfway decent. Yeah. And so the next weekend I made a stiffer version. I made them a little shorter, and we went out to Hollister. Where are you located, by the way?
I'm in Middle Tennessee, Nashville area.
Okay. So you know the whole Windrock scene and all that stuff.
Oh, yeah.
Yeah. Gotcha. Have you ever been out west? Do you know what I'm talking about when I say Mendocino?
Yeah. So I lived in Colorado Springs for a couple of years as well. So I got the whole Western experience as well.
Okay, gotcha. So yeah, I went to a 4x4 park out in the SF Bay area, and I just brought a whole bunch of different prototypes, and I tried them. And one thing I noticed was I could hear air like getting squished out of them. And so I took my Leatherman and I stuck it into the side of it, and I made a little hole, and you could feel air being pushed out of it. Wow. And I was like, okay, this is like, we could do something with this, right? Like, it's not just a bug, it's a feature.
Yeah.
Let's iterate on it. And so after 50 or 60 revisions, I brought it to market, and I'm up to, I've gone through 150, 160. A lot of them are little tweaks, right? Like, it's a lot of like making it easier for me to process, making it easier for customers to identify part numbers. But some of them are huge. Like the Gen 2 upgrade was a substantial one, right? And so, yeah, that's kind of how it all came about. It was a bit of a necessity. Once you run bump stops on these trucks, it's like, oh wow, I can't believe I went so long without it.
Yeah,
right?
Yeah, for sure. You kind of walked us through it a little bit here, but what are some of the experiences you took from Apple that you're implementing into this role?
One of the biggest ones was collecting data.
Yeah.
And that was something that early on I was like, weigh every part. Okay, parts are in spec, ship them. But then it was like, all right, like track it, right? And so I track every part that comes off the machines into a big old spreadsheet. And every couple of weeks, I actually started taking everything there, pasting it into ChatGPT and saying identify trends. And it'll tell me, hey, printer 9 is trending downward. That usually means, hey, I've got a nozzle that's clogging, or hey, I've got a barrel that's starting to get bored out, right? And that gives me a really, really good read on machine maintenance, which is, I build my own machines, so understanding those maintenance intervals is really kind of unknown right now.
Yeah, right.
And so it's like, instead of having to wait for something to break, I can say, hey, this machine is starting to trend somewhere. I can have parts ready to go, and I make all the parts in-house. So that all starts to get a little easier, right? Sure. So that was huge. And another one was just communicating with customers. I didn't do that at Apple, but just in general, communication was really huge there, and is still really huge here. And I think I've failed if I don't respond to someone in a day, and I usually respond in a few hours. So
nice. Would you say that like building your own business has been more fulfilling than working a corporate job?
Dramatically. Yeah. Not to say anything bad about corporate, but there's nothing like having, someone leaves a review. It's a representation of you. It's a representation of what you do, and how you conduct your business is a direct mirror of who you are as a person, right? And it's so much more rewarding to not be under an umbrella.
Absolutely. Man, tell everybody where they can find you, where they can find your parts, and where they can follow you on social media.
So I'm located in Lebanon, New Hampshire, but I am traveling to multiple locations. I'll be at Overland Expo West this year, and I'll be at Cruisers on the Rocks every year, and then maybe Overland Expo East. And then website is perryparts.com, www.perryparts.com, or you could just search for off-road bump stops. It'll come up there too. What was the last part? Oh, social media. Yeah. So, pretty active on Instagram right now. Looking to do some more long-form content on YouTube in the near future. Those are my main two platforms.
Nice, dude. You got me pumped up. I'm going to have to get me a set of bump stops for next season. And
I'd love to hear that, man.
Yes, sir. Awesome. Thanks for coming on, man. Appreciate the time.
My pleasure. Thanks for having me on.
Yes, sir. Have a good one.
Take care.